Hello students, hope you are in good health by the grace of good God. Today we are going to start with acid, bases and salt. You have already learned in your lower classes, but still in this year in class 10 you are to learn acid, bases and salt. To precisely go through acid, we should come across the definition first of acids. What is acid? It was discussed by Savante, Arrhenius, Bronsted and Lowry, and finally by Lewis. So while we go for the definition for acids, you are to know how acid was being discussed by this fellow scientists Savante Arrhenius, Bronsted and Lowry and Lewis. Savante Arrhenius stated that an acid is a compound which, when added in water, furnish hydronium ion as the only positively charged ion. So students, just check it here. Savante Arrhenius, he stated that an acid is a compound which when added to water furnish hydronium ion as the only positively charged ion. I would ask you to go with the word only, because whenever H3O plus is produced or being furnished only as a positively charged ion, we can call them as an acid. Like hydrochloric acid is an acid. Why? Because when you are adding to water, it produces hydronium ion as the only positively charged ion. There is no other positively charged ion. While Bronsted and Lowry, they discussed acid in a different way. They said that an acid is a compound, and acid is a compound which can donate a H plus ion. So whoever can donate an H plus ion is called as an acid. Here you can see hydrochloric acid is an acid. Why? Because when it is added to water, it donates this H plus ion and it forms H3O plus ion and Cl minus. So as it can give this H plus ion, it is called as an acid. So Bronsted and Lowry, they discussed acid as a compound which can donate H plus ion. In Lewis, the concept is something different. An acid is a compound which can accept a lone pair of electrons. So an acid is a compound which can accept a lone pair of electrons. If I take here compound like BF3, and if you take ammonia as NH3, nitrogen has got a lone pair of electron, it can donate to BF3. So BF3 is an acid because it can accept the lone pair of electrons present in ammonia towards itself. So Lewis said that an acid is a compound which can accept a lone pair of electrons, and BF3, or you can also have AlCl3, they are acid because they can accept a lone pair of electrons. By this time, you have already come to know that acids, all acids contain hydrogen. There is no such kind of acids which do not contain hydrogen. So all acids contain hydrogen according to Arrhenius and Lewis. Is it right? No. It is Arrhenius and Bronsted and Lowry. And in case of Lewis, he stated very clearly, whoever can accept the lone pair, they could have or they do not have, that doesn't matter in case of Lewis. Now let us focus our next projection to classification of acids. Here we have classified acids according to 5 such kind of division: 1, 2, 3, 4 and 5. So according to the source, one is organic, another is the inorganic. The organic one we are obtaining from the organism, that means plants and animal. Like we are getting citric acid, CITRIC, citric acid from all lemons. We are getting tartaric acid from the tamarind. We are getting oxalic acid from amla or tomatoes. We are getting malic acid. We are getting malic acid from apples, lactic acid from the milk. So they are either the plant or the animal origin. But when we are going with the inorganic acids, they are obtained from this earth, from non-animate or inanimate objects. Like we are getting the hydrochloric acid, sulfuric acids, nitric acids. We are getting H2CO3 as carbonic acids. We get phosphoric acid, H3PO4. So all these are inorganic acids. When we go for the strength, we divide the acid as strong acids and weak acids. Who are the strong acids? The acids which when dissolved in water furnishes almost completely into ions are called as strong acids. Let me give you an example. Say if I take HCl and add to water, say I have taken as 100 molecules and there was H3O plus and Cl minus. At the beginning there was 0, 0 at the beginning. Before I have added to water, it was 100 molecules, but now when I am adding to water, the number of molecules became maybe 2 molecules and the ions became 99%. This is 2%. The remaining is 2%. There was 100% here. This was 0%. Now it has come to 2%. The molecules remain as 2%. Ions become more. So in that case, we call this as the strong acid. So when the concentration of ions become more, we call this as strong acids. And if I take H2CO3 and then add to water, it brings up again H3O plus and CO3 2 minus. So here it forms H3O plus. Previously if I take 100% and here 0%, but now after adding to water, it is becoming around 67%. And here you have around 33%. So very less number of molecules have been ionized. So they are termed as weak acids. I will give you some examples. So students, here I have given you some names of the strong acids. Apart from these, all other acids we can put as weak acids. Hydrochloric acid, sulfuric acid, nitric acid, the chloric acids, the hydrogen bromide as the bromic acid, hydrogen iodide, methyl sulfonic acid and para-toluene sulfonic acid, these are all strong acids. While we go for the weak acids, like maximum of them would be the organic acid, this is called the formic acid, CH3COOH, this is acetic acid. So students, like citric acid, tartaric acid, oxalic acid, malic acid, lactic acid will be under the weak acid. Keep remembering these two at least, methyl sulfonic acid and para-toluene sulfonic acid. They are the organic acid, but still they are the strong acids. They are not weak acids. But the majority of the organic acids goes with as weak acids. Now when we go for according to the concentration, we can also classify acid, that is concentrated and dilute form. Concentrated where there is almost or no water in it. Only the acid is there is no water. And in case of the dilute, more is the water, less is the acid. So when the concentration of the water is more, we call this as dilute. And so actually concentration is about the amount of the acid which is present in the water. So one we call it as concentrated, the other is called dilute. But while you dilute the acid, you have to keep in mind that you have to add acid in water and not the reverse one. Why? Because it is an exothermic reaction. And once the reaction is exothermic, there can be a good amount of heat escaping out and it can splash water, it can burn up your face. So be sure that you are keeping the test tube far away. You keep the vessels far away from your reach and add acid to water and not the reverse way. This is how we divide the acid into concentrated form and the dilute form. And according to the molecular composition, that is oxyacids and the hydracids. Oxyacid, that means it should contain oxygen. If I take the name of such oxyacid like HNO3, if I take H2SO4, they contain this oxygen, H3PO4, they contain oxygen. But a hydrocide, they will not contain oxygen. For example, I can write as HCl, HBr, HI, H2S, these are all hydrocides. So oxyacids would contain oxygen, hydrocide would not contain oxygen, they would only have a negative radical and with a hydrogen. Our last thing that we should keep in mind is about the basicity. So student, you just take a note what is basicity. Yes student, get ready with your pen and the copy and you just write down basicity is defined as a number of hydronium ion that can be formed when one molecule of acid is added to water. So in case of HCl, when you are adding in the water, it is going to produce only one hydronium ion. Therefore, the basicity is 1. So what is the basicity of hydrogen chloride? The basicity of hydrogen chloride is 1 because it produces only one H3O+, part 1 molecule of acid in water. If I take H2SO4 and add water, here it produces 2 molecules of ions of hydronium ion and SO4 2 minus, therefore the basicity is 2. When I take here H3PO4 and 3 moles of water here, it produces 3 hydronium ion and the phosphate ion. Therefore the basicity is 3. When I take silicic acid H4SiO4 and put to water, it produces 4 times the hydronium ion and SiO4 4 minus, therefore the basicity is 4. So you see, it is the number of hydronium ions that is produced by one molecule of an acid. This you have to keep in mind. One molecule of an acid, when you are adding to water, how many hydronium ions it is going to furnish, this is what we call as the basicity. But this is also very important. If you take H3PO3 and add water, only 2 hydronium ions come into the process. So 2 hydronium ion and 1 H3O plus is formed here, and the basicity is 2. What is the reason behind this? I am going to show you here that H4SiO4 it have a 4, H3PO4 has 3, but H3PO4 has a basicity 2. It is because of the attachment. Phosphorus has got 5 electrons. Phosphorus has got 5 electrons, and it has to communicate with the number of oxygen here present. And you can see it is forming oxyhydrogen, a double bond O, and here again O and H. So these hydrogen are replaceable. Because they are being attached with a hydrogen bond, which is one of the weakest bonds we know. Ionic bond is a very strong bond. Covalent bond is then after it, hydrogen bond is even weaker than that of the covalent bonds. So these bonds, they can break open, and they can release this hydrogen, and the hydrogen reacts with the water to form hydronium ion. But this is not the case in H3PO3, because here you can see oxygen, number of oxygen is 3. Here in case of H3PO3, the phosphorus joins with hydrogen. So these 2 hydrogens are replaceable, and 1, 2, 3 hydrogen, and here 1 hydrogen. So you can see only this hydrogen and this hydrogen are replaceable, while this is not replaceable, and so this is what we call the basicity is 2. If you have acetic acid CH3COOH and add to water, it is going to produce only H3O plus ion and CH3COO minus. So they produce only 1 hydronium ion, so the basicity is again 1. So it doesn't matter when it have more H or less H, you have to see how many H is being attached with oxygen, because oxygen and hydrogen, they are being attached with the hydrogen bond, and being a weak bond, they can easily break off the bond, because the breaking up means the dissociating energy is more than that of the hydrogen bond, and so it can break it off. So in our next part is the preparation of acids. Very easy. Only 4 such points you have to keep in mind. One is by synthesis process. The second one is the reaction between the non-metallic oxides and water, reactions between the non-metals and acids, and by displacement process, better I say, for the non-volatile nature of sulfuric acid. So student, while we go for the synthesis or by the direct contact, you can write here direct contact. By direct contact method, here hydrogen and chlorine, when you are allowing it to pass through diffuse sunlight, it produces HCl. But if you are putting in strong sunlight, so just beneath strong sunlight, there will be a violent reaction. So be careful that when we do it, when we start the reaction, it should be under diffuse sunlight, under the shade, and if you do it in the dark, the reaction would not proceed. So better we take it in diffuse sunlight. Hydrogen and sulfur, in the presence of carbon disulfide, CS2, it works better to produce this H2 gas, H2S gas. Remember, these are how we prepare acids by direct contact. Similarly, reaction between the non-metallic oxides and water, say you take examples like SO2, SO3, CO2, NO2 or N2O5, NO2. So when you take the non-metallic oxide and water, it produces acid H3, H2, SO3. It is sulfurous acid. When you are taking sulfur trioxide and water, it produces here sulfuric acid. When you take carbon dioxide and water, it produces carbonic acid. When you take nitrogen pentoxide and water, you are going to get HNO3 twice. But when you take nitrogen dioxide and water, it produces HNO2 and HNO3 respectively. So you can see here NO2, nitrogen dioxide, when you are adding in water, it produces nitrous acid and nitric acid. But in the same time, when you take nitrogen dioxide and water and oxygen, then it is again going to produce HNO3, 2 moles of HNO3. So you have to see, student, whether oxygen is being provided or not. If it is not being provided, you are going to get two different acids. One is nitrous, another is a nitric acid. But if nitrogen dioxide is added to water and also there is a surplus of oxygen, you are going to get to nitric acids. Similarly, reaction with the non-metals and acids, these are the non-metals like sulfur and phosphorus. You can react with one acid to get another acid. So you can see, student, you are going to react with HNO3 and you are going to get H2SO4. So you can use one acid to get another acid. Like phosphorus, you take this nitric acid to get phosphoric acid. So in this way, you can sacrifice one acid to get another more acid. This is another big process, and by displacement process or the non-volatile nature of sulfuric acid, this salt, sodium salt, if there is chlorine, they react with this because sulfuric acid is non-volatile, and you are going to get an acid which is volatile in nature. You are going to get here NaHSO4 and HCl, or you may get here Na2SO4 and HCl. The thing is, here if it is above 200 degrees centigrade, you are going to get this, and if it is below 200 degrees centigrade, you are going to get this. So student, keep this in mind that when you take sodium chloride and add to sulfuric acid, remember the sulfuric acid should be a concentrated one, because concentrated sulfuric acid is non-volatile in nature, and when you are having a temperature less than 200 degrees centigrade, it is going to produce a bisalt and hydrochloric acid, and here they produce a normal salt and hydrochloric acid, and we usually accept this temperature because low temperature favors a good reaction. Why? Because less fuel is used, the apparatus, the glass apparatus would not break, and number 3, Na2SO4 forms a crust like a chewing gum. It sticks to the glass apparatus. Removing them becomes quite difficult. So to remove all these hazards, we usually take a temperature less than 200 degrees centigrade, usually 180 degrees centigrade, 180 degrees centigrade, so that you get sodium bisulfate, and it is water. It can be mixed in water, and it will not get stick to the glass apparatus. Temperature also is quite low. You need not to waste a good amount of fuel. So we usually prefer this. Sodium nitrate, similarly, if you give a temperature less than 200 degrees centigrade, it is going to produce NaHSO4 and HNO3. Similarly, if you give a temperature greater than 200 degrees centigrade, it is going to produce Na2SO4 and HNO3. So student, by this time you have understood about the preparation of acid by the synthesis process. by the reaction between non-metallic oxide and water, reaction between non-metals and acids, and by the volatile nature of sulfuric acid. You can use one acid to get another more acid. Here also you can get one acid to get another more acid. So it's very interesting to learn the preparation of acids within a wink of time. Thank you.